This is the Physics 2212 Lab 3, the magnetic field of a bar magnet, and my name is Jonathan Paparo. For the introduction, our purpose is to measure the effect of distance on the magnetic field due to the bar magnet, and we need to compare the true distances with the Biot-Savart law and visualize the magnetic fields with glow script. The lab results are that when the source point is far away from the observation point of the magnetic field approaches zero, and when the distance between the points decreases, the magnetic field increases. So they have a distance and magnetic field have an inverse relationship. N is equal to negative 2.84 and the dipole moment is equal to 4.57. The models that we are going to use are the Biot-Savart law, as shown there, the dependence distance formula, and the linearization formula, also both shown. The experiment procedure is to use the magnetometer by lining it up towards the north, and we did this by finding the magnetometer in our phones and downloading the app which allows our phones to be used as a magnetometer. And then we would measure the distance between the magnetometer and the bar magnet, and we would do this for both on axis and perpendicular, and then we would find the magnetic field strength. And the system is the bar magnet, and the surroundings are everything other than the magnet. And yeah, the condition the initial condition as is stated in the procedure as well, is that the bar magnet is aligned with the magnetometer. Yeah. This is the data that we found, and that's the linearization model. Or the linearity model. And yeah, those in the chart, there are the distances in the magnetic field at those different distances. And as you can see, as the distance increases, the magnetic field decreases, and vice versa. The data is the magnetic field in the x direction that is corrected is 9.26 e to the negative fifth, and in the z direction it's negative 2.93 e to the negative fifth, and the net magnetic field is just those added together, which is 6.5 e to, or just 6.45. Find the distance of the bar magnet at varying distances. The details are find the distance of the bar magnet at varying distances and find the y component of the magnetic field by Earth. Yeah, and then find the x and z components with the magnetometer and correct the y component of the magnetic field with the Earth. And we know that Bx is equal to 0 at large distances due to the inverse relationship between distance and magnetic field. These are the results. N is equal to negative 2.84, which is the slope of our linearity model, and the ln of k is equal to negative 13.905, which is the y-intercept of our linearity model, and then you can find k from there. And the magnetic dipole is equal to 4.57, and that was able to be found by setting those two equations equal to each other. Yeah. This is the code that I ran, and at the bottom it was used to find the magnitude of the magnetic dipole moment, which is the same as over here. Or back a slide. What I just said, setting those two equations equal to each other, that is what this code does. And the expected versus the actual data, the experimental data that we found is the B net is equal to 6.45 e to the negative fifth, and the expected magnetic field was 4.53 e to the negative fifth, and the difference between those two is about 70%. And the what if questions. What if the experiment wasn't conducted in a manner that would compensate for the magnetic north? The Earth's magnetic field would interfere with the bar magnet's field, and the results would be skewed. And what if you were to stick two identical magnets end to end and run the experiment again? The magnetic field would double, assuming the distance is still the same. And in conclusion, the bar magnet can be modeled as a dipole, and the distance and magnetic field strength have an inverse relationship. And sources of error would be not correctly orientating the phone pointed north would skew the data, and also not turning off any electronics that are in the room that would produce their own magnetic field and skew the data.